From the question, MA is equal to 0.8, MF is equal to 99, the DC voltage supply VD is equal to 400 volts, and the fundamental frequency F1 is equal to 50 Hz. For part A, we have to calculate the RMS, fundamental line-to-line output voltage, which equals to √3 over 2√2 and the whole times MAVD. Which equals to 195.9592 volts. For part B, we have to find the frequency spectrum of the output voltage showing the dominant harmonics. And we have to tabulate these values first to draw the frequency spectrum. N is always an odd value. N is equal to 1 for the fundamental frequency. Fn is the frequency in Hertz, and the harmonic component VON in volts. We know that MF is 99, and for the dominant harmonics, we have the peak at the fundamental frequency where n is equal to 1, then MF plus minus 2, MF plus minus 4, 2MF plus minus 1, 2MF plus minus 5, 3MF plus minus 2, 3MF plus minus 4. These values, we have obtained them using the normalized RMS values of individual harmonics. This equal to 9701. I have already calculated the values. 95 103, 197 199, 193 203, 295 299, 293 301. And for the frequency, for n is equal to 1, F1 is equal to 50 Hz. For the second value, 97, we have to multiply 97 by 50, and the same apply for all other values which I have already calculated. It is 4850 Hertz. The remaining values I'm going to write them. And for the harmonic component, using the first part where we have calculated the RMS fundamental line-to-line voltage, where we have been asked to find the RMS value, but for the harmonic component, it is not the RMS value. Therefore, we note N, we are using a common formula to find the different values for the harmonic component column. We note N is equal to root 2 divided by 2 root 3 divided by 2 root 2 times MA times VD, and to cancel the RMS value we have to multiply by square root 2, which gives us final formula of root 3 over 2 MAVD. And for these values as well, I have already calculated them. I'm just to have to plot them. For N is equal to 1, the harmonic voltage is equal to 277.19, then 76.20, 2.83, 108.60, 4.53, 61.10, 36.20. The frequency spectrum is as follows. It is a graph of the harmonic voltage against frequency Fn. For n is equal to 1, we have a peak voltage of 277.19 volts. For MF, at MF plus minus 2, $4,850. Hertz and 5050 Hertz. The harmonic voltage equals to 76.2. And at 2 mf plus minus 1, at mf plus minus 4, these 4750 and 5150, the harmonic voltage is equals to 2.83 volts. At n is equal to 2 mf plus minus 1, which gives a frequency of 9850 and 9950. The respective voltage equals to 108.60. And for other frequencies, as obtained from the table, we have just to plot them on the graph. For part C, the question is divided into two parts. First, we have to estimate the THD in line voltage and then the THD in the line current. Using the values from part B, we have already calculated the frequency and the harmonic voltage component in the line voltage, line to line. And what we have to calculate now is the different values of Zn for respective frequencies, and also the harmonic current. For the second part, In, this also corresponds to the line to line current. I have already calculated the values of Zn using this formula. Zn equals to R square plus omega L a whole to the square, and it is square root where omega is equal to 2 pi Fn. And for the value of current, the harmonic line-to-line current, which is also equal to I LLN equals to V naught N divided by Zn. This is equation 1, and this is equation 2. The corresponding values for Zn with respect to the frequencies for the fundamental frequency, Zn is equal to 10.10 ohms, and R is equal to, we know that it is equal to 10 ohms, and the inductance L is equal to 5 millihenry. Now we have just to complete the table. All values have already been calculated, and they are as follows. The values are given in 2 decimal places, and for the harmonic current, they are as follows: 15.83, 0.28, 0.27, 0.01, 0.01, 0.2, 0.2, for this frequency, the value is neglected because it is too small. This is 0.08, and for the last frequency it is 0.05. For part C, we need to estimate the total harmonic distortion in the line voltage per phase. And the following equation is used. Where THDV per phase is equal to VLL RMS phase to the square minus VLL1 RMS per phase to the square. The whole is square rooted and then divided by VLL1 RMS per phase. We already has the value in part A for VLL1 RMS, and to find VLL1 RMS per phase, we have to divide VLL1 RMS by square root 3. Which equals to 195.9592 divided by square root 3 equals to 113.14 volts. For VLL RMS per phase, it is calculated as follows, which is equals to VLL node RMS divided by the root 3, where VLL node RMS equals to the summation of n is equal to 1 to infinity VLL n divided by square root 2, the fraction to the square, and the whole is square rooted. And using these values for the harmonic voltage components, where V naught n is also equal to VLLN, and this value is equal to 247.10 volts. Therefore, VLL RMS per phase equals to 247.10 divided by root 3, the solution equals to 142.66 volts. Now for THDV per phase, it equals to 142.66 to the square minus 113.14 to the square, whole is square rooted and then divided by 113.14 times 100, where THDV is expressed as a percentage value. 142.66 to the square minus 113.14 to the square, square rooted, and then divide by 113.14 times 100. The answer equals to 76.8%. Answer is given to 1 decimal place. To calculate the total harmonic distortion in line current per phase, the following equation is used, where ILL1 RMS equals to ILL1 divided by root 2 equals to 15.83 amperes divided by root 2, and the per phase line to line fundamental current ILL1 RMS per phase equals to ILL1 RMS divided by root 3 equals to 15.83 divided by root 2 multiplied by root 3 equals to 15.83 divided by root 6 is equal to 6.46 ampere. For ILL RMS phase, it is equal to I ILL RMS per phase is calculated using this formula, and using these values for the harmonic current IN, which is also equal to ILLN, the value is 11.2 over root 3, which gives us 6.4663 or 663 ampere. So the HDI per phase equals to 6.4663 to the square minus 6.46 to the square whole square rooted, and then we divide by 6.46 multiply by 100, and the final answer equals to 4.4% to 1 decimal, please.